Hello, everyone, and welcome to our next session. I've got Tomasz here, another core developer from Parity. He's going to talk about Substrate's RPC endpoints. I'll let you take it from here, Tomasz.
Thank you. Hi, guys. My name is Tomasz. I work at Parity, obviously, and I would like to tell you a little bit more about RPC endpoints today. So what I mean when I say RPC, RPC is the interface between your application and the blockchain client. We use something that is called JSON RPC, a protocol that is called JSON RPC. Why do we use it? Mostly because it's now a crypto industry standard. It originated from a Bitcoin client that had this interface. Later on, Ethereum took this on and also expanded a little bit. And this is what we have right now as well, because mostly because everyone expects us to have this kind of interface because they are used to it. So it comes in two flavors. A JSON RPC over HTTP server and over WebSocket server. Why do we have both? Primarily because these are both web technologies. So it allows your applications to be just web applications running in a browser and then connecting directly to the blockchain client. HTTP is also very good for quick prototyping, quick checking, because this is a request response protocol, just as the JSON RPC is. So it's very easy to send a query and then get a response. WebSocket, however, is also really cool because it has a persistent connection and it allows us to do a little bit more. So we have an extension over JSON RPC, which allows us to send notifications to connected clients. And that's only available over WebSocket interface. So as I said, it's inherited, but we have made some amendments to it as well. Primarily, we have some namespaces in our RPC methods. So they are organized into, I think, 5 or 6 different categories that I will go over on the next slides. Then we have way more subscriptions than, for instance, in Ethereum client. I would really like to say at some point that we are subscription first, but we are not there yet, unfortunately. But we are definitely striving to be able to push more data to the clients instead of have clients pull for this data constantly. There is no accounts management, and that's a decision we have made very early on in the process. Your account doesn't belong to the blockchain client. This is something that the RPC clients should deal with, and ideally it should be something that is completely external, maybe a hardware wallet for maximum security. There is no indexing, or rather minimal indexing. Indexing is cool because you can get this kind of structured data directly from your client node. But the problem is that it requires a lot of effort. It requires a lot of database space, and it's never perfect. There are many different use cases, and people want to index different stuff. So it's really better to use something that runs along with your blockchain client and does this indexing. For instance, we provide a thing called Substrate Archive, which puts all the blocks and extrinsic into a PostgreSQL database. So you should definitely check it out. Then we strive to make this interface lean and runtime agnostic. Unfortunately, this means that there is a little bit more on the client side, a little bit more work on the client side that you have to do. But that's sort of like a trade-off that you have to pay for this forkless runtime upgrades. There are also tools that are this sort of RPC attachments that you can run. For instance, the Substrate API sidecar is one, and this provides you with a more high-level API for frame-based runtimes. So what do we have like out of the box when you start your Substrate node? So there is this 6 different namespaces that we support, and this is something we call core RPCs. And I'm going to go into more details of each of this category. So first of all, we have the system namespace. And this encapsulates all the queries that you can do that will tell you something about the state of the blockchain node itself. Not the blockchain, not the runtime, but just the client that is running on your computer. So you can get a version name, a version and a node name, what roles it's configured for, what chain it's actually syncing, and what network it's connected to, what are the peers, and what is its health. So in bold, I try to put like my personal choice of the most interesting RPC in that category, and this is node health, which will tell you if your node is doing a major sync right now, plus if it's connected to enough peers. So if it's in this like healthy state. Next, we have author namespace. So I said we don't deal with accounts, with your keys. There is an exception. We do that for block production right now, but this is also something that we are working on. We are working on offloading that into external signers so that the nodes that produce blocks can stay more secure. There is transaction pool inspection API, and most importantly, a way to submit transactions to your blockchain node. Note that these transactions have to be signed already. So this is something that the RPC client has to deal with. Next, we have blockchain access under chain namespace. So it allows you to query blocks, which is headers, and their bodies, which is just a list of transactions that are in that block. All these methods are hash-based queries, so we don't support numbers because numbers, like querying by block number, is ambiguous. It means there might be multiple blocks under the same number because you have different forks. So we decided that we don't support that. We only support hash-based queries so that this notion of what is returned under a particular number doesn't really change. Most importantly, you can get block finality notifications. So when your chain is finalizing or some finality gadget is finalizing blocks on your blockchain, your RPC client will get notifications when that happens. So you can follow the finality chain as well. There is off-chain namespace for accessing off-chain database, which we also call local storage. And that's something that is used by your off-chain workers and the indexing API. If you don't know what the indexing API is, have a look, take a look at the documentation. It's a really cool feature. I don't want to go into more details, but a combo of off-chain workers and indexing API is really interesting. And we allow you to modify and query the off-chain worker persistent storage through RPC as well. And then I think that the most commonly used namespace, maybe the most important as well, is state namespace. This allows you to retrieve the state of your blockchain, which means whatever your runtime is storing, whatever your runtime is writing into the state tree, this is what you can query under this namespace. As I said earlier, note that this is runtime agnostic, so we don't really know what runtime is storing there, which means your client needs to know how to access this data. And now you might say, okay, but it's too generic. We want something that is more tied to a specific runtime. And this is a problem that we have actually run into very early on as well. For instance, if you are building your runtime with Frame, which is sort of a default, then it has this concept of accounts and nonces, which means that every transaction that is being sent from a particular account needs this increasing number called nonce, so that we know what is the ordering of that transactions, and these transactions are not replayed. But this is a concept that just exists in the runtime. the entire Substrate node doesn't have any notion of nonce at all. The transaction pool doesn't need it. None of the RPCs need it. So now, if you want to send a transaction from your application, what you have to do is you can query the state and read what is the next expected nonce. And that should work fine most of the time. But if there are any transactions in the transaction pool from the same account already, then there will be this nonce conflict. So to properly get a next nonce for some account, you actually have to collate informations coming from the state and from the transaction pool. And this is already pretty involved. So we have decided to kind of find a solution for this and help blockchain developers to tackle that issues or similar issues that they might have. And we've introduced RPC extensions. Each of your palette or your entire runtime might extend the default set of core RPCs with their extensions that are specific to that particular runtime. So for instance, the frame system palette adds an RPC method, I think it's called system account next nonce, which gives you the next nonce for a particular account, which actually has this logic implemented in Rust. So what the RPC extensions look like? First of all, you have your palette, and here you can see on this listing, you can see transaction payment palette from Substrate. And there is your palette code in source directory over there. Then your palette, to expose a palette-specific RPC, it needs to create a runtime API, so something that will expose the internal state of the palette or internal logic of that palette outside of the runtime. And then you can wrap this runtime API into RPC code, which will add a bunch of RPC methods that you can later on extend your node with. So there is like a little bit of boilerplate, but it should be fairly straightforward how to create your own methods. When you have this extension ready, when we initialize Substrate service, so during the creation of your node, there is a sort of a hook where you can add your custom RPCs and extend the default set. Here I have an example from node template. This is bin node template node source RPCRS file, where you can see that we create something that is called IO handler, and we extend this IO handler with our custom RPC implementations. So we add this frame system APIs that I've mentioned earlier, so this account next nonce, and we add this transaction payment API that I was also showing on the previous slide. This gets bundled into Substrate service, and when you start your node, it will have this additional RPCs exposed. So now, when you are building a UI or you are building a client application, you can be sure that the core RPCs are there. But what about these other custom RPCs? So we've added this kind of meta call, which allows you to query all RPC methods that the node supports. And the UIs or applications can use that to change their behavior accordingly to what is actually exposed by the node. And for instance, this is what Polka.js apps is using. So when you can connect it to a node that doesn't support system account next nonce, and it will fall back to some other mechanism. So there is a bunch of gotchas when you are creating either if you are contributing to Substrate by extending the core RPC, or if you are creating your own RPC extensions for your own blockchain, that you have to have in mind when you are doing this. So for instance, encoding of numbers and numbers, I mean large numbers above U64. These numbers should be encoded as hex. If you have applications that are written in JavaScript that might be consuming this RPC. The reason for this is that JavaScript doesn't really have good number precision implementation. So the types that are in JavaScript don't support big numbers. And if you are using a default JSON decoder, which is just like JSON parse, it will actually parse these numbers into JavaScript numbers. And if they are larger than U64, then you will lose some precision there. So a general rule is to encode numbers, large numbers as hexes, and then parsing these hexes in JavaScript into, for instance, a big number library. Secondly, if you have a stream of bytes or a vector of bytes that you want to expose in RPC, it requires additional SERDI annotations to be hex encoded instead of using a default SERDI encoding, which is just an array of numbers. Obviously, there's nothing wrong with an array of numbers, but it's just very human unreadable, and it's very, like hex encoding is much more compact. You're exposing your RPC nodes publicly is also pretty tricky. We have some means of making it simpler for you. So there is a set of safe and unsafe methods. And by default, when you are exposing your node, we will disable all unsafe methods, which are the methods that allow you to mostly like modify the state of your client. But even with this, there are still possible DOS vectors that someone might try to exploit. So in general, if you are trying to expose RPC interfaces publicly, make sure to use some kind of proxies and make sure to use rate limiting so that you don't let your nodes being killed. I've mentioned when I was saying about the chain APIs, I've mentioned that they are hash-based, which means that if you want to query a specific block, you just give a hash of that block and we will give you all the details. But in most of the methods, this parameter is optional. If you don't provide the hash, we will default to the latest block. But have in mind that if you are calling a bunch of methods in a batch, or one after the other, then you shouldn't be relying on, there might be a case where this block actually changes in the meantime. So you query the header, then you query the set of transactions, and it might be a set of transactions for a different block because there was one block imported in the meantime. So a recommendation here is that you first figure out what block hash you want to query. If you want to query the latest block, then just get the latest block hash first, and then issue all subsequent RPC methods by making sure this hash is actually fixed and is passed as a parameter to all these RPCs. As I said, with the authoring API, the RPC servers or the Substrate node expects the transactions to be already created correctly and signed. We just accept a scale encoded block that is directly passed to the runtime for verification. So the RPC doesn't really help you with creating this transaction. And this requires a lot of effort. So if either you have to hard code your transaction information in the application, or if you want to be runtime agnostic, then you should be parsing the metadata that the runtime has to make sure you are producing the right transactions. And there are some ongoing efforts on the tooling of this side. So what's next? The main thing that we are working on currently with the RPC code is rewrite from an old library that we are using that is bound to old futures version to something completely new that our own Tomaka wrote that is more async await friendly. And this is an ongoing effort. You can find a link to the library in the slides, and check out the V2 branch, which will hopefully pretty soon be integrated to Substrate as well. So we want to work on more fine-grained safe-unsafe support. Right now, this is something that we have on a single method level. But if the method is marked as unsafe, you will still see it in RPC methods, although calling that method will simply fail. So we want to provide this safety information outside for the clients as well, and if the node is running in the safe or unsafe mode. We have a very rudimentary client support right now, and you can in Substrate codebase you can find an example of RPC client. But since it's using this old library, it's also based on this on old futures, which should also be solved by the migration that I've mentioned earlier. Creating your own RPC extensions requires a bit of a boilerplate code, as you have seen earlier. And we had some discussions on making it easier to actually auto-wrap this runtime APIs into RPC calls. Versioning is something that has been discussed extensively many times as well. Currently, the API is quite stable for some time, but we don't really have a good way of doing backward compatible changes. And that's something we want to solve at some point as well. And there is a lot of effort going on the tooling to interpret the metadata, so something that I've mentioned earlier as well. Obviously, for JS, we have the excellent Polka.js API, but the efforts are mostly on the Rust side, and there are two projects that might be interesting. It's dsub and subxt. Yeah, and that would be actually all from me. And I think we still have some time for the questions. Or not.
Actually out of time now. We've gone a little bit over.
Okay, I'm so sorry.
No worries. You're only 2 minutes over. It's fine. But as previously before, you can join Tomasz and the rest of the team on Discord to answer any questions that you might have there. Thank you so much, Tomasz.
That went really fast. Thank you. See you on Discord, guys.
Yeah. Okay, I'll see you in the next session.